All right, on number 1, you have f of x equals 4 raised to the negative x power minus 10. Now remember from us talking in class that 4 to the negative x, that negative is up in that exponent, so it's going to do something horizontally to my graph. If you have a negative sign, it's going to do a reflection. It's either reflecting horizontally across the y-axis or vertically across the x-axis. In this case, this negative sign is up in the function, so it's going to do it horizontally. So here we have a reflection. So this graph right here is going to reflect across the y-axis. So here's the original. Remember, I have that y-intercept at 0, 1. Here's the original. This negative sign takes and reflects that across the y-axis. Still, I have the y-intercept of 0, 1, but my graph now turns and it decays. So that's a reflection across the y-axis. Now, this minus 10, that's happening outside the function, so that does it vertically. So it's going to shift down 10. So I have a reflection across the y-axis. My graph shifts down 10. So I'm going to take this. Remember, my original asymptote is at y equals 0. So now my new graph has shifted down 10. I'm actually not going to draw down 10. I'm just going to go down 10. And my new asymptote has moved down to y equals negative 10. Everything shifts. So this graph, this whole graph, so my y-intercept has also shifted down 10. I know my asymptote is always one below that, so I'm going to put right there's my y-intercept, and I'm just going to swoop it down. This is just for me. So there's what this graph looks like. So what do we know about the domain of any exponential function? The domain of any exponential function is all real numbers. What about the range? The range is lowest y value to highest y value. So the domain of the range is negative 10 not included to positive infinity. The asymptote is y equals something. Y equals that line that you'll never get to. So y equals negative 10. The end behavior, as x approaches, well, I'm going to come over here and jump on my graph. As x is approaching negative infinity, what's my y value doing? It's going up. So as x approaches negative infinity, f of x approaches positive infinity. As x is approaching, and I'm going the other way, x is approaching positive infinity, that y value is going lower and lower, but it will never go below y equals 10. So as x is approaching positive infinity, f of x approaches my asymptote. Remember, one of these 4 numbers right here has to be your asymptote. So as x approaches negative infinity, f of x approaches positive infinity. As x approaches positive infinity, f of x approaches negative 10. And this graph is decreasing. Number 2, you have f of x equals negative log base 3 of x minus 1. So I have my original logarithmic function. I know my asymptote is at x equals 0. My x-intercept is at 0, 1. Here's what the original logarithmic function looks like. It's the inverse of the exponential. This negative sign is outside the function. It reflects me vertically, so it reflects across the x-axis and shifts down 1. So I'm still here. My asymptote is still at x equals 0. I'm turning this graph upside down. It's reflecting upside down. So it's going this way now. And that minus 1 shifts all of this down 1. So here's the graph that I'm going to be looking at. My domain, my vertical asymptote is still at x equals 0. My x-intercept, everything's shifting down 1. So I'm just going to pull this down 1, swoop it. So there's what that graph looks like. The domain is not negative infinity to positive infinity. It can't go past that asymptote. So the domain is 0 not included to infinity. What's the range of a logarithmic function? Every time. Always all real numbers. The asymptote of a logarithmic is always x equals something. It's x equals 0 unless you had a horizontal shift somehow, and I did not have a horizontal shift anyway. I had a reflection across the x-axis, and I shifted down 1. Make sure you're writing your translation. Shifts down 1. All right, so my asymptote is still at x equals 0. My end behavior, as x approaches as far left as I can get. Well, when I come over here and jump on my graph, I can't go past x equals 0. So as x approaches 0, what's the y doing? It's going up. So as x approaches 0, f of x approaches positive infinity. And I'm going the other way. As x approaches negative infinity, f of x is also approaching negative infinity. So as x approaches positive infinity, f of x goes down. So x is approaching, as x approaches positive infinity, f of x approaches negative infinity. And this graph is decreasing. I'll stop right there. I'll do 2 at a time. That way if you miss, you can just go look at 2 at a time instead of having to watch all of them. So I'll do another video for 3 and 4.